is my screen visible to you?
Yes, sir.
Ma'am.
Yeah. Okay, so today we are going to revise remaining part from unit number 3, that is operations on sets. So there are different operations those we can perform on set, like union, intersection, symmetric difference, Boolean sum, like this. Okay. So today we are going to revise all those operations. So first operation is a intersection operation. So intersection of any two sets A and B is written as A intersection B. So this is the symbol for intersection. So what is meaning of this intersection? It is a set consists of all the elements which belongs to both A and B. Okay. So here we can say that the intersection is what? Whatever elements those are common between set A and B, those will represent intersection of A and B. So how we can represent it by symbolically? So this is the symbol for intersection A intersection B. So here we are going to take intersection between set A and set B. This is what? The common elements between set A and set B. So this can be defined as for any element x such that that element x belongs to set A and belongs to set B. So here we are going to find such elements. Those are present in set A as well as in set B. Okay. So this is the meaning of this intersection operation. So then there are some equalities like A intersection B. This is equals to B intersection A. Again, A intersection A is equals to A, and A intersection phi is equals to phi. Okay. So here we have to see the proofs for all these statements. Before that, take the definition for intersection and its symbolic representation. I will give you 2 minutes. Within 2 minutes, you have to complete it. Write down definition for intersection and its symbolic representation. Okay, now first we will see proof for A intersection B is equals to B intersection A. Okay. So first of all consider LHS. So LHS is A intersection B. So we can consider any element X. Suppose that element X belongs to A intersection B. So this is equivalent to X belongs to, we have kept this X belongs to as it is. Now write the definition for A intersection B. We have seen that definition is for any element X, X belongs to A and X belongs to B. So just we have replaced this A intersection B by its definition. That's why X belongs to for any element X such that X belongs to A and X belongs to B. Till now, just we have written definition for A intersection B. Okay. Now in the next step, we can say that for X belongs to such that X is member of A. So this for this one we can say that meaning of this statement is X belongs to A. Okay. Again, X belongs to, for any element X, X belongs to B. Means what? X belongs to B or X is a member of B. Again, now this is a conjunction operation. So we can change the position of variable A and B or set A and B. Like A conjunction B, this is equivalent to B conjunction A. Likewise, X belongs to A, conjunction X belongs to B, this is equivalent to X belongs to B, conjunction X belongs to A, or and X belongs to A. This would just we have changed the position of sets. So again, here we can write for this X belongs to, we can take common. Again, B and A. So for any element X, that X will belong to B and X belong to A. So this we have taken from this step number 3. So what is meaning of this whole statement? B intersection A. X belongs to B intersection A. Now keep this X belongs to as it is and check for this curly bracket. What we have written in this curly bracket, that is for any element X such that X belongs to B and X belongs to A. So this is the definition for B intersection A. That's why here X belongs to A intersection B. This is equivalent to X belongs to B intersection A. Again, if you cancel this X belongs to from both the side, you will get A intersection B. This is equivalent to B intersection A. So here we have proved this first statement. Likewise, we can prove for remaining statements as well. So first of all, tell me, have you understood how we have proven this statement A intersection B is equals to B intersection A? Have you got this?
Yes, ma'am.
Yeah. Okay. Now, likewise, we have to prove for this second statement, and that statement is A intersection A is equals to A. So, can anybody tell how we can prove this statement? A intersection A is equals to A. So again, for this one, we have to consider any element X. So for any X, we can write X belongs to A intersection A. Here we are going to consider LHS. So again, X belongs to A intersection A means what? X belongs to A and X belongs to A. Again, X belongs to A and X belongs to A. This means X belongs to A only. So now our LHS is X belongs to A and RHS is again X belongs to A. So again from the both the side we can cancel X belongs to. So what is remaining? A intersection A is equals to A. So without proving also we can say that A intersection A means what? The elements which are common between set A and set A. Okay. So ultimately it will give you set A only. That's why this proof is there. A intersection A is equals to A. And last statement is A intersection phi is equals to phi. So again, there would be some elements in set A, but set phi means what? It is a empty set. That's why nothing will be there. So if you take intersection, if you are looking for the common elements between A and phi, ultimately it will give you phi only because phi is a empty set. So if you take intersection of any set with phi, all the time you will get phi only. Okay, because phi is a empty set. So there is one property for this intersection, and that property is called as associativity. Means what? If you consider three sets as A, B, C, then A intersection B intersection C, this is equivalent to A intersection B intersection C. So here just we have changed the brackets, and this intersection satisfies associativity property. So this is regarding first operation on set, and that operation is intersection. So if you want to take proof for this one, you can take, and for remaining two, you have to write by yourself. Just now we have discussed it, how to write it. So just take down the proof for A intersection B is equals to B intersection A. Then we will see the next operation. And for these two statements, you have to write those proofs by yourself. So just take note of that, and as a homework you have to solve it. Okay. So now we will see the next one as our next operation is a disjoint operation. So what is meaning of this disjoint? Suppose there are two different sets A and B, then these sets are called as disjoint if A intersection B is phi. So what is meaning of this statement A intersection B is equals to phi? Means what? If there is no any element common between set A and set B, then only we can say that these two sets are disjoint, mutually disjoint. Now, next point is disjoint collection or mutually disjoint. So, disjoint collection means what? A collection of sets is called as disjoint collection if for every pair of sets in the collection, two sets are disjoint. The element of disjoint collection are said to be mutually disjoint. Okay. So already we have seen what is meaning of disjoint. If nothing is common between any two sets, then those two sets are called as disjoint. Now, what is meaning of disjoint collection? Collection is what? It will be a collection of sets. So, if you consider any two sets from that collection, then for those two sets there should not be any element in common. Then only we can say that that is a disjoint collection, and such a collection or member of such a collection is called as mutually disjoint. Okay, so this is the concept of disjoint. Now here one example is given, and from that we have to recognize, we have to show A1, A2, A3 are mutually disjoint. Okay, so first consider the pair of sets as A1, A2. Now check whether anything is common between these two sets. No, nothing is common. That's why we can say that A1 intersection A2, this is equals to 5. Okay, that's why this pair is mutually disjoint. Again, if we consider the second pair as A1, A3, so now check whether anything is common between A1 and A3. No, again nothing is common because A1 is containing two elements. First element is set 1, 2 and second element is set 3. But if you look at A3 just containing one element, and that is set 1, 2, 3. That's why nothing is common between A1 and A3. That's why A1 intersection A3 is equals to 5. So these are the mutually disjoint. Again, if you consider pair A2, A3, so again, nothing is common. That's why A2 intersection A3 is equals to 5. So here we can show that A1, A2, A3 are mutually disjoint as nothing is common between any two pairs of sets. Okay. So this is the concept of mutually disjoint. So just take this definition for disjoint. Two sets A and B are called as disjoint if and only if A intersection B is equals to 5. That is, A and B have no elements in common. Next one is for disjoint collection. So definition for disjoint collection: a collection of sets is called as disjoint collection if for every pair of sets, if for every pair of sets in the collection, two sets are disjoint. Two sets are disjoint. The element of disjoint collection are said to be mutually disjoint. Okay. And take down this example. Now, in the next example, they have shown we have to show that A is subset of B. This is equivalent to A intersection B, and this is equals to A. Okay. So first of all, we have to see what is meaning of A is subset of B. Okay. So we have seen this concept of subset for element X. If X belongs to A, then X belongs to B. So this is the meaning of A is subset of B. Okay. Now this is equivalent to A intersection B, as they have said. So what is meaning of A intersection B? Again, for any element X, X belongs to A and X belongs to B. Okay. And this is equals to X belongs to A. Okay. So first we have seen X belongs to A. If any element X, if that element X belongs to A, then only X belongs to B. Because we have taken here A is subset of B. म्हणजे जर तो एलिमेंट A मध्ये असेल तरच तो B मध्ये असणार आहे. ओके. अगेन A intersection B काय असणार आहे मग? All the elements those are common between A and B. And first statement आपण काय लिहिलंय? A is subset of B. म्हणजे A चे जेवढे एलिमेंट आहेत ते सगळे B मध्ये असणार आहेत. Then only we can say that A is subset of B. And this statement we have written A intersection B is equals to A. Yes, because all the elements of A are present in B. That's why if you take intersection of A and B, you will get A only. That's why we have written this proof. Are you getting this? Have you
Yes, ma'am.
understood?
Yes, ma'am.
Yeah. Good. Next operation is union operation. So this is exactly opposite to intersection. So in the intersection we were looking for the common elements. But for this union operation we have to take all the elements from either set from A or from B or from both A and B. Okay. So what is the definition for this union operation? For any two sets A and B, the union of A and B is written as A union B. Okay. So this is the symbol for union. Is this set of all elements which are members of set A or set B or both. In short, that element should be present in either set A or in B or in both A and B. And symbolically it can be written as A union B is equals to for any element X such that X belongs to A or X belongs to B. So this is the definition for union. So if you check the difference between union and intersection, for A intersection B, what we had written here, this or is replaced by and. Okay. Then it will give you intersection. So this is the definition for union. Again, this union operation is commutative operation. Why? Because A union B is equals to B union A. Again, A union phi is equals to A. Why? Because if you consider A, set A and set phi. Phi means what? Empty set. Okay. Nothing will be there in set phi. So all the elements, those are present in A, those will be in A union phi. That's why answer is set A. Likewise, again A union A means what? All the elements those are present in set A and again set A. If you take union, repetition will not be considered. That's why A union A is equals to A only. So this is for union operation. Take down the definition and its symbolic representation. Then we will take these properties. So first of all, write down definition for union operation and its symbolic representation. Okay. So now we will discuss the properties satisfied by this union operation. First property that we have seen, that is the commutative property. So A union B, this is equals to B union A. Again, A union phi, this is equivalent to A, and A union A, this is equivalent to A only. Again, the second property satisfied by this union operation is associative property. So A union B union C, this is equals to A union in bracket B union C. So again here just we have changed the brackets. So here we have taken what is meaning of A union B union C. So if you consider any element X, we can say that X belongs to A, or X belongs to B, or X belongs to C. So this is the meaning of A union B union C. Again, A union A, this is equivalent to A only. So how we can prove this? So consider there is any element X which belongs to A union A. So we can keep this X belongs to as it is. Now we have to replace this A union A by its definition. So for any element X such that X belongs to A or X belongs to A. So here just we have written definition for A union A. Okay. So what is meaning of this? X belongs to, for any element X, X belongs to A. Means what? X belongs to A. Or again, X belongs to, for any element X, X belongs to A. So again, its meaning is X belongs to A only. So X belongs to A or X belongs to A. This is equivalent to X belongs to A only. So here X belongs to A union A, and on right side X belongs to A. So if you cancel X belongs to from both the sides, you will get A union A. This is equals to set A. So in this way we can prove any statement which is the proof. So likewise you can prove for A union phi is equals to A. So take this statement for homework and solve it. A union phi, this is equals to A. Also you have to prove this associative property. A union B union C, this is equals to A union B union C. So take this one for homework, and while coming to the next lecture, it is solved. So do you want to write this proof for A union A is equals to A? Or shall we see next point? Hello? Okay. So take down this proof for A union A is equals to A. So here again we have to solve some examples based on union and intersection. Both of the S union Q and S intersection Q if S is equals to say A B P Q and Q is equals to say A P T. Okay. So here we have to find out union and intersection between these two sets. So first we will check for union. So what is meaning of union? The elements those are either in set S or either in set Q or in both S and Q. So first we will write the elements of set S, and those elements are A, B, P, Q. Those we have written here. Now we will check for set Q. If there is any repeated element, then we will skip it. Now A and P, these are repeated, that's why we are going to skip it. and what is remaining? T, element T, which is present in set Q only. That's why here the S union Q is equals to A, B, P, Q and T. So in the next point we have to find intersection of S and Q. So what is meaning of intersection? The elements those are common between S and Q. Now check, A is common, again P is common. That's why S intersection Q is equals to A and P. Okay. So this is the based on union and intersection. Again, the next example is also based on union and intersection. So here three sets are given, A1, A2 and A3. So A1 is set 1, 2, A2 is 2, 3 and A3 is 1, 2, 3, 6. So here we have to find out union of AI such that I from 1 to 3. Means what? We have to take union of A1, A2 and A3. Again, intersection of AI such that I from 1 to 3. So again, we have to take intersection of A1, A2 and A3. So first we will solve for union operation. So again, union of these three means what? We have to combine all elements from all these sets. So elements from A1, these are 1 and 2, we have written here. Again for A2, 2 and 3. So here 2 is repeated, so that we are going to skip, and remaining element is 3 that we have added here. If you consider A3, 1, 2, 3 already we have taken. So just 6 is a new element. That's why that element we have added here in union operation of A1, A2, A3. That's why final answer is set 1, 2, 3, 6. Okay. Element which is common between all three sets like A1, A2 and A3. So 2 is common in A2, A1, A2 and A3. That's why for this intersection operation there will be only one element in set and that element is 2. So likewise we can solve the examples based on union and intersection. Have you understood these two operations?
Yes, ma'am.
Okay. Do you want to take these examples? I think nothing is difficult here. So we can go for next operation. So next operation is a relative complement. Okay. So what is meaning of this relative complement? Let A and B be any two sets. The relative complement of B in A is written as A minus B. Is this set consists of all the elements of A which are not elements of B. Okay. So A minus B means what? Here we have to take relative complement of A with respect to B. Okay. And that relative complement is written by this minus sign, that is A minus B. Means what? The relative complement of A with respect to B. So here we can say that A minus B means what? All the elements which are present in set A but not in set B. That is A minus B. So how we can represent it by symbolically? A minus B, this is equals to for any element x such that x belongs to A and x does not belong to B. आपल्याला असे एलिमेंट बघायचे आहेत जे ए मध्ये आहेत पण बी मध्ये नाही. दॅट इज मिनिंग ऑफ ए मायनस बी. अगेन दिस इज इक्वल टू फॉर एनी एलिमेंट एक्स such that x belongs to A and negation of x belongs to B. So here this x does not belong to B is written as negation of x belongs to B. meaning of these two sets is same. So this is the relative complement of V in A, and this is also called as difference of A and V. So relative complement or difference operation. So take down definition for this operation. So now next point we have to see is a absolute complement. So this is the next operation on set, absolute complement. This is similar to the relative complement. Only difference is that here we are going to take that complement with respect to set E, that is universal set. So let us see definition. Let E be a universal set. For any set A, the relative complement of A with respect to E, that is E minus A, is called as absolute complement of A. The absolute complement of set A is often called as complement of A, and it is denoted by negation of A. So symbolically, it is written as negation of A. This is equals to E minus A. This is equals to for any element X such that X belongs to E and X does not belong to A. And this is equals to for any element X, X such that negation of X belongs to A. Okay. So what is meaning of E minus A? That is absolute complement. All the elements, those are present in universal set E but not in set A. म्हणजे काय सेट ए मधले असलेले सगळे एलिमेंट सोडून बाकीचे जे युनिव्हर्सल सेट मध्ये एलिमेंट असणार आहेत that is called as absolute complement of set A with respect to E. That is E minus A, and this is equals to negation of A. A मधले सोडून बाकीचे एलिमेंट means negation of A. So take down the definition for absolute complement and its symbolical representation. If you are not getting any point, tell me here only. So I will repeat it once again. Okay. So check for the next one. So negation of negation A is what? This is equivalent to A only. Negation will get cancelled and final answer is A. Again, negation of phi. This is equals to E. So phi means what? It is a empty set and E is a universal set. So negation of phi. It will give you set E. Again, negation of E, this is equals to phi. A union negation of A, this is equals to E. And A intersection negation of A, this is equals to phi. म्हणजे काय असा कोणता इलेमेंट असणार आहे का जो A मध्ये आहे आणि नाही ते? No, there will not be such an element. That's why A intersection negation of A, this is equals to phi. So here we have taken the proof for A union negation of A, this is equals to E. So how we have proven this? A union negation of A means what? For any element X, X belongs to A or X does not belong to A. जे काय असे इलेमेंट जे X मध्ये आहेत पण आणि X मध्ये नाहीत पण सॉरी A मध्ये आहेत पण आणि A मध्ये नाहीत पण. So that will give you universal set because universal set E will include all the elements in universe. That's why this is equivalent to E. So here some examples are given. So three sets are here A, B, C, and we have to find A minus B, B minus A. Again we have to show A minus B, this is not equals to B minus A, and A minus C, this is equals to A. So one by one we will solve it. First one is A minus B. So what is meaning of this A minus B? The elements those are present in set A but not in B. So can you tell me what is the answer for A minus B? Hello? What is the answer for A minus B? जागे आहेत का सगळे? हां काय? Okay, 5, 6 is correct. Because if you consider the elements, those are present in A but not in B. 2 is present in A and that is also present in B. That's why we are going to skip it. So 5, 6, this is the answer for A minus B. Set 5, 6. Now next one is B minus A.
3,4.
B minus A. B मध्ये आहेत पण A मध्ये नाहीये.
3,4.
Is set 3, 4. Now here we have got the answer for A minus B and B minus A. From that we can say that A minus B is not equals to B minus A because A minus B is set 5, 6 and B minus A is set 3, 4. That's why these two sets are not equal. Now we have to show that A minus C is equals to A. So first of all tell me what is the answer for A minus C? A मध्ये आहेत पण C मध्ये नाहीये.
Set of 2,5,6.
2,5,6.
Yes, set here. Set 2, 5, 6. And this is set A only. That's why A minus C is equals to A. Now, next one is show that A minus B is equals to A intersection negation of B. So how we can prove take down this proof for A minus B? Is screen visible to you?
Yes, ma'am.
Okay. So take down the proof for A minus B equals to A intersection negation of B. So in this second proof, they are asked A subset of B. This is equivalent to negation of B subset of negation of A. So now we have to prove this second statement. So LHS is A is subset of B. So how we can write the equivalent form for this one? So here we can replace this by definition of subset. So for any element x, if x belongs to A, then x belongs to B. So this is the definition for A subset B. Now, if you want to reverse the order of elements, like here in the first step, A is the first element and B is the second element. If you want to reverse this order, that is B tends to A, then you have to take negation from both the sets, and that we have done in second step. That is, for any element x, negation of x belongs to B, then negation of x belongs to A. So meaning of these two statements is same. X belongs to A, then x belongs to B. Means what? Negation of x belongs to B, then negation of x belongs to A. Again, what is meaning of negation of x belongs to B? Means what? X does not belong to B. That's why for any element x, x does not belong to B, then x does not belong to A, because we have taken here negation. So what is meaning of this? X does not belong to B, then x does not belong to A. Means what? Negation of B is subset of negation of A. Here we have applied definition of subset. सबसेट म्हणजे काय? जर तो एलिमेंट पहिल्या सेट मध्ये असेल तरच दुसऱ्या सेट मध्ये असणार आहे. नाउ हियर negation is there. Means what? If that element is not present in first set, then it will not be present in second set. That's why negation of B is subset of negation of A. So take down this proof. Have you understood it? How we have proved this? Hello. तू कसं केलं समजले का? का रिपीट करायचे?
करा मॅम.
Okay. What we have written here, A is subset of B. Okay. So what is meaning of subset? Subset ची definition काय बघितली? If you consider any element x, if that element x is present in set A, then only it will be present in set B. That is meaning of subset. जर A मध्ये सगळे element B मध्ये असतील तरच आपण काय म्हणणार आहे? A is subset of B. So here we have considered just one element x. आता x हा जर A मध्ये असेल तरच तो B मध्ये असणार आहे. So how we can write it in symbolic form? For any element x, if x belongs to A, then x belongs to B. जर तो element A मध्ये असेल तरच B मध्ये असणार आहे. Okay. Now, if you want to reverse the order of elements, आता पहिल्यांदा आपण सेट A घेतले and second time सेट B घेतले. जर आपल्याला ती ऑर्डर रिव्हर्स करायची असेल, पहिल्यांदा बी घ्यायचं असेल तर आपल्याला त्याचं निगेशन घ्यावं लागतं. दॅट्स व्हाय फॉर एनी एलिमेंट एक्स, negation of x belongs to B, then negation of x belongs to A. Okay. Here we have taken negation in order to reverse the order of sets A and B. पहिल्या स्टेप मध्ये A tends to B होतं. आपल्याला आता काय पाहिजे? B tends to A. Because what we have to prove here? A is subset of B. This is equivalent to negation of B subset negation of A. जे आता इथे B पहिल्यांदा आहे तर ती ऑर्डर रिव्हर्स करण्यासाठी आपल्याला निगेशन घ्यावं लागतंय. सो negation of x belongs to B tends to negation of x belongs to A. Okay. The negation of x belongs to B means what? X does not belong to B. So if X does not belong to B, then X does not belong to A. And this is equivalent to negation of B subset negation of A. म्हणजे काय, जर तो एलिमेंट बी मध्ये नसेल तर तो ए मध्ये पण नसणार आहे. सो दिस इज मिनिंग ऑफ निगेशन बी सबसेट निगेशन ऑफ ए. जसं आपण म्हटलं ए इज सबसेट ऑफ बी वेन all the elements of A are in B. So likewise, negation of B is subset of negation of A. If म्हणजे काय सांगू शकतो आपण, जे एलिमेंट बी मध्ये आहेत ते ए मध्ये नसतील, म्हणजे बी मध्ये नाहीये ते ए मध्ये पण नाहीये, देन ओनली वी कॅन से दॅट निगेशन ऑफ बी इज सबसेट ऑफ निगेशन ऑफ ए. फक्त निगेशन ऍड केले बाकी वेगळं काही नाहीये. जस्ट वी हॅव टू अप्लाय द डेफिनेशन फॉर सबसेट. Have you understood now? Hello?
Yes, ma'am.
So now we have to see the next example. Here again we have to prove one statement. For any two sets A and B, A minus A intersection B, this is equals to A minus B. Okay. So first of all we are going to consider LHS. So for any element X, X belongs to A minus A intersection B. Okay. So again here we have kept this X belongs to as it is. Now we have to replace this A minus A intersection B by its definition. So what is meaning of A minus A intersection B? Means what? All the elements those are present in set A but not in A intersection B. Okay. So here X belongs to, we have kept as it is. Now apply the definition for A minus A intersection B here. That is, for any element X, X belongs to A and X does not belong to A intersection B. जे A मध्ये आहे पण A intersection B मध्ये नाहीये. That is meaning of A minus A intersection B. Now, X belongs to A and X does not belong to A intersection B. So what is meaning of this does not belong to? This can be written as negation of X belongs to A and X belongs to B. Okay. So again, X belongs to A and now apply this negation over this bracket. So X does not belong to A. This and should be replaced by or X does not belong to B. Okay. So here we have to apply distributive law. So X belongs to A and X does not belong to A, or X belongs to A and X does not belong to B. So what is meaning of this first bracket? X belongs to A and X does not belong to A. म्हणजे काय? एलिमेंट X असा आहे जो सेट A मध्ये आहे पण आणि नाही पण. No, but there will not be such an element. That's why answer for this first set or first bracket is 5. Okay. So just consider second bracket, that is X belongs to A and X does not belong to B. Means what? The element which is present in set A but not in B, and that is equivalent to A minus B. So in this way we have proved this part as A minus A intersection B. This is equals to A minus B. Have you understood this proof? Hello? समझले का है प्रूफ?
Yes, ma'am.
Okay. So take it down. So we will see next point then. So now we have to see the last operation on set, and that operation is symmetric difference or Boolean sum. Okay. So first we will see the definition. Let A and B be any two sets. The symmetric difference or Boolean sum of A and B is set A plus B and defined by A plus B, this is equals to A minus B union B minus A. Okay. So here plus operation is for symmetric difference or Boolean sum. If there are two different sets A and B, then symmetric difference or Boolean sum of A and B is given by set A plus B, and that can be represented as A plus B is equals to A minus B union B minus A. म्हणजे काय जे एलिमेंट आहेत ए मध्ये आहेत पण बी मध्ये नाहीये और बी मध्ये आहेत पण ए मध्ये नाहीये. So union of these two sets gives us A plus B. So again, this can be written as for any element x belongs to A plus B, this is equivalent to x belongs to for any element x such that x belongs to A exclusive or x belongs to B. Okay. So this can be replaced by exclusive or also A minus B union B minus A. In short, A exclusive or B. So there are some equalities are given like A plus B is equals to B plus A. So this is a commutative property. Second one is a associative property, that is in bracket A plus B plus C is equals to A plus in bracket B plus C. Next one is A plus phi is equals to A only. A plus A, this is equals to phi, and A plus B, this is equals to A intersection negation of B union B intersection negation of A. So all these are properties of this Boolean sum. So first of all, take down the definition for Boolean sum, then we will check for equalities. Now take down these equalities. So there are total 5 equalities for this Boolean sum. Okay. Now we have to prove a plus 5 is equals to a. Okay. So how we can prove this? Consider any element x. Now x belongs to a plus 5. So what is meaning of a plus 5? We will keep this x belongs to as it is. So now replace this a plus 5 by its definition as x for any element x such that x belongs to a and x does not belong to 5, or x belongs to 5 and x does not belong to a. Okay. So what is meaning of this? X belongs to a and x does not belong to 5, or x belongs to 5 and does not belong to a. Okay. First bracketचं meaning काय आता? x belongs to a and x does not belong to 5. म्हणजे काय? जो एलिमेंट a मध्ये आहे पण 5 मध्ये नाहीये. आणि सेकंड ब्रॅकेटचं मिनिंग काय? 5 मध्ये आहे पण a मध्ये नाहीये. असा कुठला एलिमेंट असणार आहे का जो एम्प्टी सेट मध्ये आहे पण सेट a मध्ये नाहीये? नो. Empty set means nothing will be there. So answer for this second bracket is false. Okay. So again x belongs to a and x does not belong to 5. a मध्ये आहे पण 5 मध्ये नाहीये. ओके. 5 म्हणजे एम्प्टी सेट. सो त्यामध्ये काय असणारच नाहीये. सो x belongs to a म्हणजे काय येणार आहे मग? अगेन x belongs to a or false. So its answer is x belongs to a. So again from the both the sides we can cancel x belongs to. That's why a plus 5 this is equals to a. So here just we have applied the very easy. Just we have to remember the definition for that particular operation. So is my voice breaking
Yes, ma'am.
still now? Hello?
Now it is clear.
Okay. So now we have to see the second statement. A plus a this is equals
Hello?
to 5. Hello? Yes?
मॅम परत एक्सप्लेन करा.
हे लास्ट प्रूफ का?
हाँ.
Okay. So what we have written here? A plus 5 this is equals to a. Okay. So first consider LHS, that is a plus 5. Now consider any element x. If x belongs to a plus 5, this can be written as x belongs to. Now here we have to apply the definition for a plus 5. Okay. So x belongs to, for any element x belongs to a and x does not belong to phi, or x belongs to phi and x does not belong to A. Here just we have applied definition for A plus phi. A plus phi म्हणजे काय? A minus phi union phi minus A. Again, A minus phi म्हणजे काय? The element those are present in A but not in phi. Union phi minus A. So again, the elements those are belong to phi but not in A. Just we have given that definition here. So again, x belongs to A and x does not belong to phi, or x belongs to phi. It belongs to phi, does not belong to झाले. X belongs to phi and x does not and x does not belong to A. म्हणजे काय असा कुठला एलिमेंट असणार आहे का जो एम्प्टी सेट मध्ये आहे पण सेट ए मध्ये नाहीये. ऍक्च्युली एम्प्टी सेट मध्ये कुठलाही एलिमेंट नसतो. दॅट्स वाय मीनिंग ऑफ दिस सेकंड ब्रॅकेट इज फॉल्स. म्हणजे याला काय अर्थच नाही. वी कॅन स्किप दिस. ओके. नाउ फोकस ऑन फर्स्ट ब्रॅकेट. x belongs to A and x does not belong to phi. म्हणजे काय असा एलिमेंट आहे जो सेट ए मध्ये आहे पण फाय मध्ये नाही. फाय मध्ये कुठलाच एलिमेंट नसतो. त्यामुळे दिस कंडिशन इज ट्रू. दॅट्स व्हाय x belongs to A and x does not belong to phi. So what is meaning of this? That element x belongs to A only. That we have written in this state as x belongs to A. Or value for this second bracket is false. That's why or f. Again, so what will be the answer for x belongs to A or f? f बरोबर तुम्ही डिसजंक्शन मध्ये काही पण घेतलं, ट्रू घेतलं किंवा फॉल्स घेतलं, त्याची व्हॅल्यू कशावर डिपेंड असणार आहे? x बिलोंग्स टू A. जर ह्या ब्रॅकेटची व्हॅल्यू ट्रू असेल तर फायनल आन्सर तुमचं ट्रू येईल. अदरवाइज if this is containing value as f, then you will get final answer as f. So the value of this statement is depend upon x belongs to A only. That's why its answer is x belongs to A. Now what is in LHS? X belongs to A plus phi, and what is at RHS? X belongs to A. So if you cancel x belongs to from both the sides, you will get A plus phi is equals to A. Have you understood now?
Yes, ma'am.
Okay. So the next statement is A plus A is equals to phi. So again here we have to apply the definition for A plus phi. So can you tell me how we can define A plus A? A plus A म्हणजे काय असणार आहे? Apply here definition for Boolean sum. Tell me this one with in the form of relative complement. A plus A. This will be equivalent to A minus A union A minus A. Okay. इथे बघा definition आपण काय लिहिले? Symmetric difference or Boolean sum. A plus B असेल तर कसं लिहिणार आहे? A minus B union B minus A. So likewise here in our example set is A plus A. So this can be written as A minus A union A minus A. Okay. So same definition we have to apply here. A plus A, this can be written as A minus A union A minus A. So what is meaning of A minus A? Any element x which is present in set A but not in set A, because both the sets are A only. So A minus A म्हणजे काय? Element जो A मध्ये आहे आणि नाही पण. Or again same element which is present in set A but not in set A. म्हणजे असं कुठला एलिमेंट आहे का जो सेट ए मध्ये आहे पण आणि नाही पण? नो. सो दॅट्स वाय इट्स आन्सर इज 5. दॅट इज एम्प्टी सेट. प्रूफ समजलं का? Here just we have applied definition for Boolean sum a plus a. Hello?
Yes, ma'am.
Yeah. Now the next proof is a plus b. This is equals to a intersection negation b union b intersection negation a. So first of all consider LHS a plus b. Okay. So for any element x, we can write x belongs to a plus b. This is equals to x belongs to. Now write here definition for a plus b. Just we have seen that a plus b means what? The element which is present in set A but not in B, or present in B but not in A. That we have written here. X belongs to A and X does not belong to B, or X belongs to B and X does not belong to A. Now what is meaning of this? X belongs to A and does not belong to B. That is A intersection negation B. Element which are present in A but not in B. Or X belongs to B and X does not belong to A. This can be written as B intersection negation of A. And that is our RHS. That is A intersection negation B, or union B intersection negation A. Have we understood this proof? Hello? समजलं का प्रूफ? तर रिपीट करायचं परत.
मॅडम रिपीट सांगा एकदा. रिपीट करा.
हो हो. काय प्रूव्ह करायचं आपल्याला? a plus b this is equals to a intersection negation b union b intersection negation b. So now just consider LHS. LHS मध्ये काय? a plus b. Now consider any element x which belong to a plus b. So how we can write this in equivalent form? As x belongs to, this x belongs to, we have kept as it is. Now replace this a plus b by its definition. So how we can write the definition for a plus b? A plus b म्हणजे काय असतं? A minus b union b minus a. Now consider first bracket a minus b. So what is meaning of this a minus b? The elements which are present in set A but not in B. So this can be written as x belongs to A and x does not belong to B. So this is meaning of A minus B. Or second का B minus A. So what is meaning of B minus A? Elements those are present in B but not in A. That's why x belongs to B and x does not belong to A. Again, so x belongs to A and x does not belong to B. म्हणजे काय ना? A intersection negation B. Negation का घेतला? Because that element does not belong to B. That's why negation B. Union or you can write any symbol. B and x does not belong to A. Does not belong to A means what? Negation of A. That's why B intersection negation of A. समजलं का आता काय केलं? फक्त
Yes,
डेफिनेशन अप्लाय केली. ओके.
मॅम ते युनियन घ्यायचं का और घ्यायचंय?
और आता प्रूफ मध्ये त्यांनी युनियन दिले ना, तर फायनल स्टेपला युनियन जेव्हा तुम्ही LHS इज इक्वल्स टू RHS दाखवणार ना, तेव्हा युनियन येऊ. मीनिंग सेमच आहे, पण त्यांनी प्रूफ मध्ये युनियन विचारले. सो टेक हिअर युनियन.
ओके मॅम.
You presenting? Roll number 1,
Present, ma'am.
2, roll number 2, 3, 4,
Present, ma'am. Hello.
okay,
Hello.
yeah. Roll number 5, 6,
Present,
okay,
ma'am.
5, yeah. 7, 8,
Yes, ma'am.
9,
Yes, ma'am.
10, roll number 10, 11,
Yes, ma'am.
12, 13, roll number 13, 14,
Yes, ma'am.
15,
Present.
16,
Yes, ma'am.
17,
Present.
18, 19,
Yes, ma'am.
okay, 20,
Yes, ma'am.
21,
Yes, ma'am.
22,
Present, ma'am.
23,
Present.
okay,
Present, ma'am.
20, 24,
Present, ma'am.
25,
Yes, ma'am.
26, 27, 28,
Present, ma'am.
29,
Yes, ma'am.
30,
Present, ma'am.
31,
Yes, ma'am.
32,
Present, ma'am.
33, 34,
Present, ma'am.
35, is 34 is present, 35, 36, 37,
Present.
38, 39,
Yes, ma'am.
40,
Level, sorry. This is a 0.
41, 42,
Yes, ma'am.
43, 44,
Yes, ma'am.
45,
Yes, ma'am.
46,
Yes, ma'am.
47, 48,
Yes, ma'am.
49,
Yes, ma'am.
50, 51,
Yes.
50 is present,
51 present, ma'am.
52, 53, 53, 54,
Yes, ma'am.
55. Yes, 54 is present. 55, 56,
Yes, ma'am.
57,
Yes, ma'am.
58, 58, 59.
Yes, ma'am.
Who is 59? 59,
Ma'am, Rishikesh Laur. Yes, ma'am.
60. Yeah. 60,
Yes, ma'am.
61. Yeah. 61,
Present, ma'am. Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64, 65,
मॅम तो प्रेझेंट आहे पण त्याचा माईक चालत नाही.
66,
65.
Present, ma'am.
67,
Present, ma'am.
68, 69,
Present, ma'am.
70.
Present, ma'am.
Okay. So check for today's absent numbers. 12, 13, 26, 27.
Ma'am, 26 is present.
Okay.
Madam, 13 is present.
13.
1-3.
Okay. 12, 27, 33, 35, 36, 38, 41, 47, 52, 53, 55, 58, 64, and 68. Any
Ma'am,
correction?
58 is present. 55 present, ma'am.
55 present आहे. प्रेझेंट घेताना कुठे होता?
मॅम ते डिस्कनेक्ट झालं.
Okay. So now you have to solve quiz on unit number 1. आपण फर्स्ट टाइम जेव्हा घेतली होती तेव्हा मला वाटते थोडेसे रिस्पॉन्स आले होते, त्यात कनेक्टिव्हिटी प्रॉब्लेम होता. So I will share you link on your WhatsApp group. So click on that link and solve that quiz. And time for that is 20 minutes. So link is shared on your group. Check it and solve.